Hello everyone. Today we'll see bolted connections, design of bolted connections in design of steel structures. So we'll see design of bolted connections in design of steel structures. Introductions to structural fasteners. So steel structure is an assemblage of beam, column and tension members. So steel member consists of beam, column, tension members. So it consists of both flexural and compression members. Member connected by means of fastener act as a single unit. So if you want to, so it is a combination of different structural elements. So we need to connect those members by means of fasteners. So that I can so that the whole structure is behave as a single unit. Okay. Connections required for extending the length of the different type of members. So if you want to extend length of the members, if you want to extend the length of the member in steel structures, if you want to extend length of the members in steel structures, at that time, so we need a at the time, what is that we need we need a fasteners to those connections. Okay, those things. So connection is required to extend the length of the different type of members, and desirable to avoid connection failure before member failures. Okay, so this is very important. And basic goal of connection design: produce a joint safe, economical and simple. So our what is the goal of our connection is to produce a joint safe, economical and simple. Okay. Common method of fasteners are rivets, bolts and welding. So these are different type of fasteners or connections we use in steel structures. A different method of connections we will use in steel structures, that is rivets, bolts and weldings. Okay. Now rivets are replaced by bolts. Earlier in older days we used to use rivets for as a connection for the connections of the steel members. Nowadays we are using bolts. So now we can say the rivets are replaced by bolts. Rivets are replaced by bolts. So this is the thing. Next, yeah, here you can see. So if you want to give connections from beam to column, column to beam, or beam to column, or column to beams, so we can see I can use the fasteners are connections by using. If you want to give the joint, you want to provide the joint between the beams and columns. Yeah, I can give the bolt connections here. So see, so beams and column can jointed by bolt connections. Okay. Similarly, here you can see the beams and beam passing through beam and beams connected by welding. So here beams and beams are connected by the weldings. You can see the weldings at this point. Okay, weldings. And then here also you can see as I said earlier, we can extend the members. So if you want to extend the members by means of what? By connections. What type of connections? Here you can see I can give any you either I can go with the welded connections, or either we can go with the welded connections or bolted connections. So here you can see there is a what? Connections of two members by using the bolted connections. Okay, bolted members, I can say bolted connections. So here and here also you can see in trusses, usually you see in the trusses the connections is provided by using weldings. So the members, the tension members and compression members in trusses are connected by the welding process. So we can also use the bolted connections over there. So this is how we will use the connections in steel structures, connections in steel structures. So now this is the case. Next, why connection failure should be avoided. So if you are providing the connection, so we need to take in care that the connection should be avoided. Connection failure leads to catastrophic failure of whole structures. Yeah. So if there is any smaller failures in joints, so that may lead to the failure of whole structures. The connection failure not as a ductile as that of steel member failures. Okay. So Yeah, this is very important. Connection failure is not as a ductile as that of the steel members. So the connections what you will do, it won't feel the ductile property will be revealed as it behave as brittle kind of things. So when compared to the steel members, so at the connections it will be as a brittle behavior. We can see in the connections, especially in the welding we provided. There, the failure type of failures you can see the brittle failure you can observe in the weldings. Okay, this thing. Then achieve an economical design connectors, develop full or little extra strength of the members. It is joining. Okay. So achieving an economical design connector develop full or little extra strength of members. It is joining. Okay. Then connection failure avoided by adopting higher safety of factor for joints than the members. So we can avoid these connection failures by adding higher safety of the factors. By taking higher safety of factors, we can avoid the so here safety factor at the joints we can avoid the failure of the members. Okay. Next, classification of connections. There are different type of connections we are using in steel structures. Different type of the connections we are using in steel structures. So so there is a different methods of fastening. As I said earlier, so that is first one is rivets, bolts, and weldings. Now rivets are replaced by bolts. Okay. Now commonly we will use bolts and weldings. Okay. Connection rigidity, simple, rigid, or semi-rigid. So these are the connection rigidity and joint resistance, bearing connections and friction connections. So based on the joint resistance, it will be I can classify bearing connections and friction connections. Fabrication locations, soft or field connections. Yeah, where you are fabricating those things. So those things, the elements, the joints where you are fabricating, that is the shaft or field connection. So this should be taken care. Okay. So is that you are doing, let us take a welding. Is that you are doing in a fielding or field or in the shop? You need to taken care all those things. Okay. Joint locations: beam column, beam to beam, or beam to foundations. So based on that we can classify the connections. Okay. We can classify the connections by using this. What is that? By method of fastening, we can classify rivets, bolts, and weldings. And based on connection rigidity, based on the connection rigidity, so it is can classify as simple, rigid, and semi-rigid. Okay. Then joint resistance, based on the joint resistance, is that bearing connections and friction connections. This type of bearing connections are friction connections. So that should be, we can classify. And then fabrication location. So yeah, so is that field or shop connections. So you need to taken care. And joint locations, where based on the joint locations, beam columns or beam to beam or beam to foundations. Beam to foundations. So like this, we can classify the connections. Okay. Then here also I shown some flow chart, like simple connections, then eccentric connections, like our classification of the connections I shown here. So simple eccentric connections, bolted connection, and welded connections. So in bolted connection I can see common bolts and high strength bolts. So these are two commonly used bolts. Like in that high strength bolts I can also select slip critical and bearing types. So those two types, slip critical and bearing types, as strength bolts. Okay. And welded connections, in welded connections I can see fillet weld and groove weld. This is two type. This will shows the two types of the this charts will show the type of the connections. Okay guys, so one is that eccentric connection means yeah I can what is that, bracket connections I can call it as so bracket connections, eccentric connection, those things are bracket connections. Okay. Simple connections, the bolted connections and welded connections. Here common bolts, high strength bolts. And in high strength bolts, which are all these things? Slip critical and bearing type bolts I can see. Then welded connections, there's a two type of welded connections. One is fillet weld, another one is groove weld. Okay, there's a two type of connections in so there's a two type of connections in fillet welding connections. First one is fillet weld, another one is groove weld, or sometimes also called butt weld. Okay. Then bolted connection. Let us see the bolted connections. What do you mean by the bolt? So what do you mean by the bolt? So now let us concentrate on bolted connection. Let's we take first bolted connections. Let's we take first bolted connections. Okay, what do you mean by bolt? Bolt defined as a metal pin with head at one end and shank threaded at other end to receive a nut. Okay, so guys, you can clearly see this is a head. This is a bolt. I can say the total is called a bolt, assembly is called a bolt. So here you can see, so this is head and this portion usually called as a shank. This portion, the here to here, this portion is usually called as a shank. Okay, this is non-threaded shank and this is threaded shank. You can see the threads are provided here, threads are provided. So that is threaded shank. Okay, shank portion is threaded at another end. So sometimes the usually the bolts what you see is half of the bolts will be threaded and another half will not be will be kept like this. So non-threaded portions, I can say this is shank. Total portion is called shank. So this is non-threaded portion, so it is threaded portions. Okay, and here, so usually in the connections what you will do in bolt assembly, if you take a bolt assembly, this is the total length of the bolt. If you take a assembly, this is the total length of the bolt, this is the total length of the bolt, and this is called as a nut, and these two are called as a washers, steel washers. So this is steel washers. Okay, and this is called as a steel washers they will provide before putting any. So better to get the better grips, so better, and they will provide the washers. So this is bolt assembly total. Here to here is the bolt length, here to here is the bolt length. Okay, here to here is the bolt length. So here to here is the bolt length. Okay, this portion is called shank and this portion is called shank. This is unthreaded portions and this is threaded portions. These are unthreaded portions and this is threaded portions. Okay, guys. And so what do you mean by the bolt? Bolt defined as a metal pin with head at one end and shank threaded at other end to receive a nut. Okay, to receive a nut. So one end is threaded and another end is so head at one end and shank threaded at another end to receive a nut. So this is threaded so that we can receive the nuts. Okay, so this is one case. Next, classification of fastener holes. So it's there in table number 19. Is there in table number 19 IS 800, IS 800 2007, and they're given. So what are the clearance of fastener holes? So if you want, how much clearance distance should be provided? Okay, that should be known. So bolt holes are usually drilled. So bolt holes are usually drilled. Bolt holes are made of larger than the bolt diameters. Yeah, so this is very important. So let us take So usually bolt holes are made larger than the bolt diameters. So we need to take care of this. And then why need to provide a larger diameter of the hole? Because to facilitate erections, proper erections, erections. Then next, allow for inaccuracies in fabrications, allows for inaccuracies in fabrications. Okay, so this is a case. So sometimes it may not be, let us say, I will say what is that 8 mm bolts. So 8 mm bolts. So while fabricating, it may be there is a change in the some little bit change in the diameter of those things. So it may be more than that, or it may be lesser than that. So so what is that? To allow those inaccuracies. So the diameter of the hole should be kept little bit larger than the diameter of the bolt. Okay. So why we need to use this? So we need to use this to facilitate the erection of the structures and so erection of the any structural materials and then allow for inaccuracy in fabrications. Okay, so if you want to properly fit into that hole, so the bolt should be so the diameter of the hole should be the larger than the diameter of the holes. Okay, the diameter of the hole should be larger than the diameter of the bolts. So that should be remembered. Okay, the next, spacing of the bolts. So center to center distance between individual fastener in a line in a direction of load. So center to center distance between individual fasteners So I will while doing examples, I will show this. So here, center to center. So this distance, guys, please, this distance here to here is called pitch. Here to here is called center to center. What is that? So center to center distance between individual fasteners in a line in a direction of load is called pitch. So it is there in class 10.2.2 and 10.2.3. It is given in IS 800 2007. They give the specification of load pitch, how much should be, and what is the how much lead should be, and all those things they are mentioned in clause 10.2.2 and 10.2.3. They specified the what is the maximum and minimum should be, and all those things are given. Please, you can go through the IS 800 2007. So what is that? Center to central distance between the two individual fasteners in a line in direction of the load is called pitch. So what is that? So this is called pitch, center to center line in a line of the fasteners. So a distance between two bolts in a line, I can say that is a pitch here to here, okay, along the direction of the bolt. This is called pitch. Okay, next what is that? A distance between any two consecutive fastener in a zigzag patterns of bolts measured parallel to direction of load, staggered pitch. So any two consecutive fasteners in a zigzag pattern of bolts, so staggered pitch. Okay, so means I can say, so the here to here, I can say here to here. If you take this will be the zigzag patterns. I can say zigzag patterns. So this distance is called pitch. Now if you take this distance is called pitch. This distance, okay, what is that? A distance between any two consecutive fasteners in a zigzag pattern of bolts measured parallel direction of a load. So measure parallel direction of a load. So it's a staggered pitch. Then spacing between adjacent parallel lines of fasteners transverse to the direction of load is called gauge distance. So what is that? Spacing between adjacent parallel lines of fasteners transverse to the direction of load. So means so the spacing, so you can see this, the perpendicular distance along the direction of the load between two rows of the bolts is called gauge distance. Here to here is called gauge distance. Okay, here to here it is called gauge distance. Okay, guys, here to here is called gauge distance. Here to here called gauge distance. So we need to remember these things. Spacing between adjacent parallel lines of fasteners. So spacing between adjacent parallel lines of fasteners transverse to the direction of the load or perpendicular to the direction of load, that is called gauge distance. So if it is perpendicular to the direction of load, it's called gauge distance. So so please remember this. So that is the case. Okay, center to center distance between individual fasteners in a line direction of load is called pitch. Distance between two consecutive fasteners in a zigzag pattern is called staggered pitch, and spacing between two adjacent parallel lines of fasteners transverse to the direction of load is called gauge distances. Direction of load is called gauge distances. Okay, gauge distance. Then edge are end and end distances of the bolts. Distance from center of a fastener of hole at edge of element measured at right angles to the direction of load. Direction of load at the edge distances. So placed there in class 10.2.4. So you can see this is called edge distances. This is called edge distances. Okay. This is is measured from the perpendicular to the direction of the loads. Edge distance is measured perpendicular to the direction of the loads. End distance is measured parallel to the direction of the loads, parallel to the direction of the load, or in the direction of the loads. I mean measured. Okay, to the edge. Okay. The distance from center of a fastener hole to the edge of an element measured at right angles to direction of the load is called edge distances. Then distance in a direction of a load from center of a hole to end of an element is called end distances. So it's a very important. Okay guys, so you need to remember this. So it is very important. What is the end and edge distances while doing design? These are all the main important parameter you should be remember. What is that? Distance from center of a fastener hole to the end of an element measured at right angles to the direction of a load. This is called edge distances. So this is called edge distances. Edge distances. This is called edge distances, that is measured perpendicular to the direction of the load. If you if you measure at the center of the end fastener to the center of the end fastener to the end fastener to the end of the members, end of the any members measured along the direction of the load is called end distances. This is called edge distances and this is called end distances. You should so differentiate between those two. Okay, don't get confusions between edge distance and end distances. So is there in clause 10.2.4, is there in clause 10.2.4. Similarly, it is also given in clause 10.2.4. so we can go through the IS 800 book. So here whatever I said, so it is given here, clearly shown what is the pitch and end distances, gauge distances and edge distances. Okay, this is given. Okay, so next gauge distances. So how much is there in SP6 168 page number? So how much if you want to provide gauge number of the bolts are in the angles, what should be the distance from the what should be the gauge distances they given. So is specified in SP6 168 page numbers. Is the leg size is so much, then double row bolts, single row bolts. If you are providing only single row bolts, what should be the gauge distance? And all those things is specified in SP6 on page number 168. Okay, you can go ahead with that. We can go there and you can see that what is the gauge distance should be, all those things we can refer there. Okay, then bolted connections. Okay, steel washers. So in this bolted connections, steel washers are provided under bolt and nut to serve two purposes. So here we will provide steel washers. So okay, so we can discuss later this. So this is important. Then failure of the bolts, failure of the bolt joint. So it's not have some continuity. Let us we can see this. So this is why they given means why we here we can see we provided with the steel washers. Why we need to provide steel washers? So the explanations are given here. So why we have to provide the steel washers and all those things in the bolted connections. So it basically briefly we'll go through this, like distribute clamping pressure on the bolted members, to distribute the clamping pressure on bolted members, and prevent threaded portions of bolt from bearing on connected pieces. So prevent okay, this then, and proper functioning of connections. Parts to be connected must be tightly clamped between bolts and head, and connection subject to vibrations. Nut must be locked in a position. So if the connections are subjected to vibrations, if the bolt, if the washer if you provide, so we can lock our nut and bolts properly. Okay, that's the case. Okay, then now, so failures of the bolts. So let us concentrate on now. Let us concentrate on the various failures on the bolts. So what connections, bolted connections fails in 6 ways. Some failure checked by adherence to the specification of edge distances. Okay, so this is very important. So fails in 6 ways. Usually it fails in 6 ways. Okay. Usually it fails in 6 ways. Then some failures checked by adherence to the specification of edge distances. Okay guys, edge distances. Now let us see this shear failure of the bolts. So guys, please, if you want to check the strength of the bolts, we need to check for the shear, bearing strength. There are important failure patterns, like it may fail in shear, it may fail in bearing, and it may fail in tearing parts. So all those things we need to check. Okay. So here a shear failure of the bolts. What is that? A shear strength in bolt exceeding the design strength. So shear strength in the bolt exceeding the design strength, then single and double shear failures you can see. So you can see the failure of the bolt here. The shearing of the bolt you can see. The shearing of the bolt you can then when the shear strength of bolt exceeding the shear design shear strength. Okay, the shear strength in bolt is exceeds the design shear strength, then that is we can see the failure of the bolt again single. So there is a two type I can see. There is single and double shear failure. So here you can see in a lap joint, let us say this is a lap joint. Lap joint, here you can see a single plane is subjected to shearing, so that's why it's called single shear failure. Single shear failure. Single plane is subjected to shearing here. Here you can see in these connections, two planes are subjected to a shearing. Two planes are subjected to shearing. So that's why double failures. Okay, double failures. So it's a double shear failures. Single shear and it is double shear. So why? Because double shear, two planes are subjected to shearing. Here in this example, I can say only one plane is subjected to shearing. So it is called single shear failures. Okay. That's case. Shear failures plate insufficient edge. So similarly you can see this is on bolts in plates insufficient edge distances. If you have insufficient edge distances, insufficient if you not provided insufficient edge distances, we can see the shear failure of the plate also we can see. You need to provide proper edge distances as per the specified by IS 800 2007. Okay, so we need to provide proper edge distances. Okay. Then tension or tearing failure of the plates. So tension or tearing failure of the plates. So tensile strength in a plate at a net cross section exceeds. What is that? Tensile strength in a plate at net cross section exceeds. Then tearing failure occurs bolts stronger than the plates. If the if the bolts are stronger than the plates, you can see that tearing of the plates we can occur. So if the bolt is stronger than the plates, I can see the tearing of the plates I can observe. Okay. Then splitting of plates. The bolt placed at a lesser edge distances. The bolt, you can see there is a splitting of plates I can see. So there bolt placed at lesser edge distance than the required, causing plates to split out. Okay, so if you are applying the lower forces on these directions, and if you close, so if you given the lesser edge distances or end distances, so end or edge distances, then so bolts may cause splitting out the plates. You can see there. Okay, then bearing failure of the plates. Plate may be crushed. Bearing strength of plate exceed the design bearing strength. Okay, so design bearing strength. Okay, so here what is that? Plate may be bearing failure of the plates. Plate may be crushed. Plate may be crushed. Plate may be crushed. Bearing strength in a plate exceeds the design bearing strength. Okay, so the plate may be crushed due to exceeding. So the plate may be crushed. So due to applying the forces in this directions, so you can see the plates can be crushed. The bearing failure can be so the bearing failure can be occur. The bearing strength in plate exceeds the design bearing strength. Okay, so it's very important. So what is that? Bearing strength in a plate exceeding design bearing strength. So at that time we can see the bearing failure of the plates. So you can see. So in this direction we are applying. So there is a failure of the plates. You can see failure of the plates. You can observe here and here. Okay. So this is the thing. So bearing failure of bolts. So this is very important. So bolt is what is that? How we will get this? What is that? Bolt is crushed around half circumferences. So it is crushed around half circumferences. and place stronger in bearing and heaviest stresses plate may be pressed the bolts. So if the strength of the plate is greater than the bolts at that time you may see the bearing failures. Okay. You can observe the failure. Bolt is crushed around the half circumferences. So the bolt will be crushed at the half circumferences. So you can see the bearing failure of bolts. You can see in these pictures. So we can see the bearing, and you can fractures. Ultimately, it will get fractures. These are all the fracture specimens after bearing failures. Okay. Means the strength of the plate is greater than the strength of the bolt. So at the time crushing will take place. Crushing of the bolt may take place. So I can ultimately you can see the bearing failure of the bolts in that. Okay. So this is very important. Okay. What is that? Bolt is crushed around half circumference. Okay. Bolt is crushed around half circumference. Bolt is crushed around half circumference. Now this is bearing failures. So what is that? Bolt is crushed around half circumferences. Next, types of bolts. Now let us see. These are all the different failures we can see. Yeah, we clearly discussed while designing what is that? While designing the bolts, and we have clearly discussed in the as IS codes what are the specifications are given, and all those things we'll discuss while during the design of the bolts. Okay, guys. These are the main what we discussed. These are the main failures. As I said earlier, there are 6 wave failures. What is that? And the bolt may fails in shear, due to the shearing of the plates, and due to shearing of the plates and all those things, or due to shearing of the bolts. You can see shearing of the bolts at some plane, either in shanking portions or threaded portions. In this case, shearing of bolts can take place. Okay, so the shear failure of the plate also you can see there is insufficient air resistance you provide, the shearing of the plates can also appear. Then if the tensile strength of the plate is net cross section exceeds and tearing failure occurs both times. So or if the tensile strength of the if the board is stronger than the plates, you can see the tensile failures of the plates can occur. Okay, and splitting of the plates. Yeah, if you do not provide a proper air resistances, you can see near the end or edge, you can see the tearing of the plates. You can observe. So there is no proper air resistance provided. Then bearing failure of the frets. If the plate may be crushed when the plate may be crushed when bearing strength of plate exceeds the design bearing strength. Okay, so when bearing strength is exceeding so design bearing strength, you can see there is a crushing of the plate may occur. Okay, so then next bearing failure of the bolts. So then bolt is crushed in this place. The bolt is crushed around half circumferences when because plate stronger in bearing and heaviest stress plate may be heaviest stressed plate may be pressed to the bolts. Okay, so at that time so you can see the bearing failure of the bolts. Okay, bearing failure of the bolts. The next now let us see the types of the bolts. Now let us see the types of the bolts. What are all the different types of bolts you can see here? Let us see types of the bolts. Here we have different types of bolts we'll use for the connection purposes. So let us go through this. Like unfinished bolts are black, we call it as black bolts, are C grade bolts as per IS 1363/1992. So used for bearing type connections. Okay, unfinished bolts are black bolts are C grade bolts. IS 1362/1992 bearing type of connections, used for bearing type of connections. Then turned bolts. These are all expensive and used in special jobs. So unfinished bolts are black bolts are C grade bolts like IS 1362/1992 So there bearing type of connections used for bearing type of connections Next, turned bolts. What is turned bolts? These are all expensive and used in special jobs. So used in special jobs. Okay. Precision A grade and semi precision bolts. Used for no slippage in permitted. So the A grade and A grade bolts. A grade and semi, so expensive usually in special jobs. A grade and B grade bolts, like as per IS 1364 1992, 1364 1992, 1992. So used when no slippage is permitted. Okay. So when the no slippage is provided, you can use the for A grade and B grade bolts. Ribbon bolts, rarely used in ordinary steel structures. So ribbed bolts, yeah, I will show how it is looks and all those things. Rarely used in steel structures. Next one, high strength bolts. Okay. So this is generally used for friction type of connections. So high strength bolts, like as per IS 3757 and 1985 and IS 4000 1992. That's a friction type of connections. Okay. So this is these are like the different type of bolts. These are all the different type of bolts. So as I explained, what is that? Unfinished bolts or black bolts, C grade bolts. This is okay. So these are used for bearing connections. Turned bolts. These are expensive and used for special jobs. And precision A and B grade bolts are used for no slippage permitted, and the ribbon bolts is rarely used in steel structures, and high strength bolts used for friction type connections. Okay, high strength bolts used for friction type connections. Common bolts. So common bolts are called ordinary. So now let us take this one. Common bolts are called ordinary, unfinished, rough or black bolts. Used for light structures. So if you are using for light structures like purlins, bracings, ETCs, there I will use this common. There we will use common bolts. So where the common bolts are called ordinary, unfinished, rough, and black bolts. So here. Now, what is that? Used for light structures. Like purlins, bracing, ETC under static loads. Okay, this generally used for static loads. So common bolts are used. Unfinished, rough, or black bolts. Not recommended connections subjected to impact loading, vibrations, and fatigues. Okay. Very important, guys, please. So this common bolts are unfinished, rough, or black bolts are sometimes called unfinished bolts. They're generally used for lighter structures. Like purlins, bracings, like this. And under static loads, please remember this is very important. If you're using static loads, use unfinished bolts, rough or black bolts. And please remember, this type of bolts is not recommended for impact load. When the member is subjected to impact load or vibrations, fatigue, there is not recommended. Use of this kind of bolts is not recommended. Next, bolt forged from low carbon rolled steel circular rods permitted large tolerances. So here the large tolerances are permitted. Then ordinary structural bolts are made from mild steel with square or hexagonal head. Yeah. So they made with the square or hexagonal heads. Square hexagonal head bolts are made. Okay. Square heads cost less, but hexagonal heads give better appearance, are easier to hold by wrenches, and requires less turning space. Yeah, this is very important. Here also two types of bolts will use. What is that? One ordinary structure is made up of mild steel with square or hexagonal head bolts. Nowadays, generally we are using hexagonal head bolts. In some specific places, in some cases, we are using this. What is that? Square head bolts. Rarely we can see that square head bolts uses of in structural blocks. Rarely we can see that. Okay, rarely we can see that use of square head structural bolts. But usually we use hexagonal head bolts because of it requires less space, because what is that, uh, uh, hexagonal head bowls requires less space while doing turning. Okay, little space while doing the turnings. So this is very important. Okay. Next, the common boards. So yeah, like this. So these are the common boards. So common boards that may be provided with the hexagonal heads. Okay, common boards. These are common boards. Turned boards. Yeah, you can see turned boards. These are ribbed boards. So as I explained earlier, ribbed boards. So this is a headboard and turned boards, and these are common boards generally we use. Common boards. So as I explained here, like turned boards and ribbed boards, how it looks. This is like this. This is turned boards. Okay, this is turned boards, and this is a ribbed boards. Okay, this is ribbed boards. So ribs are provided in the shank portions. Okay, then high strength boards. Uh, uh, what is the high strength bolts? So high strength bolts called friction grip bolts. High strength bolts are usually called friction grip bolts. So it's called friction grip bolts, and this high strength bolts are made up of medium carbon steel. This made with medium carbon steel. Okay, and high strength achieved. So please remember, this also called friction grip bolts. High strength bolts are called friction grip bolts, and made up of made from bars of medium carbon steels. They made from bars of medium carbon steel. So there. So here you can see this. What is that? Common bolts are made up of mild steel. Okay, is the made up of mild steel. Okay, so this is made up of mild steel, and here the high carbon are made up of medium carbon steel, and high strength achieved quenching tempering processes. Quenching tempering processes are by alloying steel. Okay. And steel washers of hard steel or carbonized steel evenly distributed clamping pressure on bolted members and prevent third portion of a bolt from bearing on connecting pieces. Okay, bearing on connecting pieces. So what is that? Steel washers of hard steel or steel washers of hard steel or carbonized steel evenly distribute the clamping pressure on bolted members and prevent threaded portion of a bolt from bearing on connecting pieces. The specification of high strength bolt is in IS 3757 1972 and IS 4000 1967. The bolts have high tensile strength several times than the ordinary bolts used in high-rise buildings, bridges, and machines, etc. Okay, high strength bolts are friction grip bolts. You can easy way of remembering what high strength bolts are friction grip bolts made from bars of medium carbon steel, and bolts have tensile strength several times than that of ordinary bolts. Highest tensile strength compared to the ordinary bolts. Okay, used in high-rise buildings, bridges, and machines. So very important. Use a high-rise building, bridges, and machines they are using. Okay, yeah, these are all the high strength word. Identified by the manufacturer, identification of symbol, property classification of the symbols. Okay, these are all the high strength bolts. Okay, advantages of high strength bolts. What are the advantages of this high strength bolts? Okay, provide high strength bolts. What is the advantages of this high strength bolts? High strength bolts provides rigid joint and no slip between the elements connected. Okay, it provides a rigid joint. So high strength bolts provides rigid joint and no slip between the elements connected. Okay, larger tensile strength developed in the bolts. So as I said, we discussed earlier, so there is a larger tensile strength developed in the bolts large clamping force to elements connected and high frictional resistance developed. That's why it's called friction type of bolts. So why? Because so this is also called what is called friction grip bolts. Why? Because it provides high resistance to the high frictional resistance to develop, provides high resistance. Okay, then because of clamping actions, load transmitted by friction only and bolts not subjected to shear and vigor. So because here I am providing with the clamp, so what is that? Because of the clamping actions, so because of clamping actions, load transmitted by friction only and bolts not subjected to shear and bearing. This is very important. That's what high strength bolts are very used for. Important works. So because the members are shank portions or bolt is not subject to that much of shear and bearings, that will be taken by frictions only. Okay, load is transmitted by frictions only and bolts not subject to shearing and bearing. Okay, the frictional resistance is effective outside the hole and lesser load transmitted through the net sections. Okay, then possibility of failure at the net section is minimized. Okay, no stress concentration in the holes, fatigue strength is more. Okay, the strength of the fatigue strength is more, and no stress concentrations in the holes can be seen in these connections. Then uh, tension in bolts uniform. Bolt tension up to proof load not prevent from loosening. Okay, few persons required to make connections and thus cost is reduced. Only some few persons is reduced requires to provide the connections, hence the cost is reduced. No noise nuisance is created. Bolts tightening with the wrenches. Hazard of fire not there and no danger of tossing of the bolts. So this is very important. Hazard of fire is not there and no danger of tossing of the bolts. And alteration done easily. We can do the alterations easily. Okay, we can do the alterations easily. So principles of high strength bolts. So also, once again, guys, please. What are the principle of high strength bolts? So shank of high strength bolts not fully fill the hole. Shear and bearing not critical for the load transmission. So what are the shank will provide? Shank of high strength bolts not fully fill the holes, and the shear and bearing not shear and bearing is not critical for the load transmission. So this is very important. A nut tighten developed and a clamping force on the plates indicated as a tensile force T in bolt and tension about 90% of proof load. Okay, a nut tightened to develop clamping force on the plates indicates as a tensile force T in bolts. Tension about 90% of the proof load. Okay, shear load applied to joint, no slip occurs until shear load exceeds the frictional resistance between the elemental joints. Further increase of load, gradually slipping brings the bolt in contact with the plate edges. So if you see this, like horizontal frictional force F produced in the joint equals to the tensile force, the word. So the F equals to mu into T. There mu is called coefficient of friction or slip factors, coefficient of frictions. We are generally use the mu is generally used for coefficient of frictions. Okay. Then frictional force F should exceed applied force P on members. So this is F equals to mu into T. So coefficient of friction. So this, mu is our coefficient of frictions. So generally two types we already discussed. So common bolts and high strength bolts. So this is a hexagonal. This is shank and this is thread. So this unthreaded portion is called shank, and usually whole thing also can shank. And this is threaded portions and the unthreaded portions I can call as. And this is thread and this is shank. Okay, bolt head, and this is nut, and the hexagonal head bolt and nut. Figures in bracket high strength bolts and nut. Okay, so this is a case. So has done both. So that's the case. So here like the force transferred on bearing type of bolts. How the force is transferred on bearing type of bolts. So bearing type of bolts. Uh, so let us see. Concentrate now. We see different type of bolts now, like high strength bolts and all those things. Let us concentrate now how the force is transferred in bearing type of bolts connections. So here I will show you the figure is show how the force is transported and transferred in bearing type of bolts. Okay. Tension in one plate is equilibrated by bearing stress between the bolt and hole in plates. Okay. Then clearance between bolt and hole in which it is fitted. Bearing stress is mobilized only after plate is slip relative to one another and start bearing on bolt. Lap joint only one critical section, and in butt joint two critical sections for the shear in the bolts. So here you can see what is that bearing stress is mobilized only after plates slip relatively one another and start bearing on the bolts. So here you can see, let us say this is lap joint. So you are applying force and tension stress. When the slip occurs on these portions, then you can see the bearing stress will develop at these portions. At this section, cross sections, the bearing will be observed. Okay. Or shearing of the bolt we can see on this portions. Shearing of the bolt we can observe on that portions. Shearing of the bolt. So lap joint only one critical section, and butt joint only butt joint have two critical sections. Butt joint have two critical sections. Please, so maybe I'll explain. I shown you people how many critical sections you can see while while telling the failure of the bolts. Here you can see lap joint have only one. Okay, so only one. Hmm? So only one connections. So this is the case. So so yeah, then so here you can see clearly see how what is that bearing of bolts. So you can bearing of the bolt. Here you can see there is a shearing bearing of the bolt can be observed here. Bearing failure of the bolt observed at the one sections. Okay. Here shearing of bolt actions. Shearing of the bolt actions. So shearing will be taken place here. The shearing of the shearing. Please, as I explained earlier, lap joint have only one critical section and butt joint has two critical sections. Okay. So, so here you can see observe that this is called a shearing failure. I can see shearing failures. Okay. Then design shear strength of bearing type of bolts. The failure of connections with the bearing bolts in shear involves failure of bolts or connected plates. So failure of the bolts. Behavior linear until yield take place and a net section of the plate under combination of tension and flexures. Shearing take place at bolt shear plane. So as I explained here, guys, please, when bearing stress exceeds these things, so the shearing will take place at these portions. Shearing of the bolt will take place at these portions. At this portion, shearing of the at the that portion. Okay, take place at the bolt shear plane. So this shear plane, you can see it is a shear plane. The two plates are connected like this. Then it is called as shear planes. So when you apply force on these directions, the failure may occur at that portions. Okay, shearing of that one. Bolts of a failure of bolt take place in bearing plates of high strength steel. Okay. So failure of bolts take place in bearing, and when the plates of high strength steel. So when the plates what are used for connected plates, connecting members, those connecting members are high strength steels. And then compared to the bolts, then I can see bearing failure of the bolt can take place. Okay, failure of the take place in bearing plate is weaker than the bolt. So vice versa, guys. Please, vice versa. So please remember, there's a three type of failures I can generally seen in the bolts. What is that? Mainly shear failures. Another one is so another one is bearing failures. Okay, bearing failures. Then next and the third one is tearing failure of the plates. Okay, tearing failure of the plates. So when the strength of the plate is more than the bolts, so at the time I can see there is a bearing failure of the plates and bolts can take place. When the strength of the bolt is higher than the plates, I can see as I explained earlier, I can see that there is a bearing failure of the plate can be occur. Okay, then so black shear failure also occurs. Okay, then design strength of the bolt. Design strength of the bolts. So here guys, please. Yeah, better I will see this IS 800. IS 800 in IS 800. IS 800 IS 800 2007, they're given what are the different type of failures will be in there in the bolts. So here they clearly specified what are the how we need to find out what is the shear capacity of the bolt and bearing capacity of the bolt, and what is the tearing or rupture strength of the plates. So in page number 75, in class 10.3 10.3.3, they will give the shear capacity of the bolt or the strength of the bolt and shear. So as I explained earlier, the bolt may fail in shear or bearing. Okay, then we need to, while designing, we need to find out what is the strength of that or capacity of that bolts. Okay, then here please is given in IS 800 2007, clearly specified what are the different type of as per specified how to we need to find out the what are the shear capacity of the bolt and bearing capacity of the bolt, and what is that here what is the design rupture strength of the plates and all those things we need to find out. Here you can see in IS 800, please go through the IS 800 page number 75 in 10.3.3, they clearly given the what is the shear capacity of the bolt, how we need to calculate it. If you are calculating design strength of the bolt, VDSB, that equals to the VNSB divided by gamma MB. What is the VNSB here? VN is the nominal shear capacity of the bolt, and that VNSB can be calculated by FU by square root 3 N into N A and B plus NS and ASB. So these are all things we'll study while doing the problems on while designing the bolts. These are all the what are all the terminologies we are using here. Here FU means ultimate strength of the bolt, what I have to use, and bolt what I have to use, and gamma MB is the partial safety factors. What is NN and NS? So we might be seeing the bolt is consist of shank portion and threaded portions. Let us say we'll assume. Let us say the so NN means the number of the, you can see here, number of the NN means number of the shear plane with the thread intercepting the shear planes. Let us say assume that your shear plane will falls in a threaded portions. Then how many number of the shear plane in there in the threaded portions we need to tell. That is NN number. So is that one shear plane or two shear plane like this. A and B means the area corresponding to that. So net shear area of the bolted threads. Similarly, NS means area number of the shear plane in shank portions. So in the bolt. Okay. ASB is the what? That is the nominal plank shank area of that bolts. Okay, that is the thing. Then bearing capacity of the bolt. We need to check the bearing capacity of the bolt. It generally gives a VDPB, bearing strength of the bolts. Generally gives VDPB. VDPB equals to VNPB divided by gamma MB, where VNPB equals to nominal bearing strength of the bolt, nominal strength, and that is taken by 2.5 into KB into D, T and FU. Here KB is the smaller of E by 3D naught, P by 3D naught, minus 0.25, and FU by FU and 1 here. What is E here? E is the end distances. Okay, and D naught is the diameter of the hole, and P is the pitch distances. FUB is the ultimate strength of the bolt. FU is the ultimate strength of the plate or connecting members what are you using. Okay, connecting members, and D is the diameter of the bolt what are you using. T is the thickness of the least thickness of the plates or connecting members what are you using, and Fu is the ultimate strength of the plate what are going to use. So based on this, I can check the what is the shear and bearing capacity of the fold. I already explained you the the bolt may fail in shear or bearing. So, or if you are checking for the bolt joint, then I need to check for the tearing or rupture strength of the plate also. Rupture strength of the plate also. That is given in page number 32 in clause 6.3.1. So we need to check the rupture strength also or tearing strength of the plate also. You are talking about the bolted joint, means we need to check even connecting members also. We need to check the strength of the connecting members also. Then we need to check what is the design strength due to the rupture of the critical sections. Here I can easily find out what is the TDN equals to 0.9 into AN FU by gamma ml. Here gamma ml is the partial safety factors, Fu is the ultimate strength of the materials, and AN is the net effective area of the members is given. Means so I can use it that AN can be calculated by using this conditions. This condition, guys, please let us say this is a zigzag portion of connections provided, bolted connections. So this is what the critical sections where I can see the tearing of the plate can occur or rupture of the plate can occur. Okay, along this path I can say ruptures can be occurred. So that's why you use this for summation of PSI squared by 4G into T. If I have only one columns like this, one hole is here, one hole is here, and hole is along the one line or one columns. If all the bolt holes are present, this is zigzag patterns. Is along if the bolt holes are there in only one single line like this. Let us take example of this only one. This 1, 2, 3 members are connected. Then this formula can be altered by AN equals to B minus N into D and N into DH into T. Okay. Because it won't be there, so that's why. So here B and T are the width and thickness of the plates what I'm going to use. N is the number of the holes along the critical lines, and DN is the DH. They are used over terminals here. DH is sometimes they also use the word DN or D naught. Okay, this is the diameter of the bolt holes. Okay, and diameter of the bolt holes what I'm going to use. So this is how we need to check what are the strength of the bolts, guys, please. So that's what the same thing is given here. You can what is the tension capacities and all those things are given here. Bearing capacity of the bolts, shear capacity of the bolts, and shear capacity of the bolts. This is what is given here, design strength of the bolts. So VDSB, as I explained earlier, we need to check for the shear capacity of the bolt. We need to check for the bearing capacity of the bolt, as I given in clause 10.3.4 page number 75. So the thing, and next we need to check for the tension capacity or rupture capacity of the plates what I'm going to use. Then whatever the minimum capacity, that will be taken for design strength. Okay, strength of the bolt. Sometimes we also call what is that strength of the bolt joint, or strength of the bolt joint. So that is how we need to find out and design the bolts. So in designing of the bolt, we need to check first what is the bearing capacity and shearing capacity of the bolts, and what is the rupture capacity of the plates. Then if you are finding out any efficiency of the bolt joints, then we need to find out all these three, and which one is the minimum. That will be the your bolt strength. That will be your not bolt strength, bolt joint strength. Okay, bolted connections, strength of bolted connections, and bolt joint. Then so we can easily find out the strength, efficiency of the bolts. So if you know what is the gross section, what is the net gross area. So gross area, and the strength of the solid plates in that solid plates, the strength of solid plates, and bolt values divided by the strength of solid plates, or strength of the bolt joint divided by the strength of solid plate, that will give the efficiency of the bolted connection. So this is how we need to find out, guys, please. So while doing during designing, we'll clearly come to know what are these terminologies and all those things. Okay, guys, I hope you understood this. So in the next class, we'll continue with the design of the bolted connections. Thank you, guys.